So at the top here, on stuff like this, we're getting to a point, and it's not on all of them here, but we're going to not only just find a rule, and that's what we were just working on before, finding a rule. We're also going to work on when I find that rule, I'm going to have to also use that rule. And then, like, it's super cyclical. Sometimes you'll use a rule to find a point to find another rule. And then on that rule, you'll use that guy as well. So it's like find rule to use rule so that I can find a rule so that I can use that rule. So it just keeps going over and over and over again. A parabola with zeros, -1 and 3, passing through point 2 and 6. I don't need to read anything else for right now. Because if I go and see a question, A, H, K, X, Y, Z1, Z2, if I am told that I have zeros, -1 and 3, and a point of 2 and 6, I know I'm going to have to find a rule. So I might as well just go ahead and do that. It's in zeros form. Y is equal to A, X minus Z1, X minus Z2. So 6 is equal to A, 2 plus 1, 2 minus 3. Okay? So then I just do my math. 6 is equal to A, 3, -1. 6 is equal to A times -3. Divide by -3 on both sides. My A will be equal to -2. So I will write out the rule. -2, x plus 1, x minus 3. Right? Now I have the rule. Okay. What am I going to do now? I'm going to go and see how I have to use it. What is the y coordinate of point B on the parabola that has an x coordinate of 4? So when it's giving me that and asking me to solve for a y, factored form, and you can write this down, factored form or zeros form, can't solve for x's, but can for y. So I don't need to convert it because I can legitimately use the rule. There's my A. I'm looking for what is y when x is 4. Plus 1, plus 1, 4, minus 3. And I reuse it twice. Okay? So what is y when x is 4 is all I have to solve for. So then y is equal to -2 times 5 times 1. Y will be equal to -10. That was me finding the rule. This was me using the rule. Because the 0 is -1, so then when I put it in, I'm going to put in opposite. It's always, if the formula says x minus something, then whenever I go inject that guy in, it's going to be the opposite value. That's why it's +1 and -3. Because it was -1 and +3. So then when I go to throw it in, like right here, +1, -3. Kind of thing. So y is equal to -10. That is basically the final answer for that guy there. Any questions on that? Okay. Number 10. Determine the range of the quadratic function f with zeros 3 and 5, which verifies f of 2 is equal to -6. Holy jumping. There is a lot to unpack with the way that that guy is worded, right? Determine the range. What is that asking me to solve? The range, yeah. What do I need to find? What specific value? What parameter do I have to solve for?
Is that H and K?
Y from
Just
bottom
K and A, yeah, bottom up. So I just need K and whether A is positive or negative. If I can figure out K and which way it's facing, I can write the range, right? So if it's facing this way, then it's going to be k to infinity is the range, right? If it's facing down, however, it'll be negative infinity to k. So that's my objective. That's how I'm going to use the rule. But holy cow, I've got to find the rule first. Okay? So determine the range of a function that has those two zeros. So I'm going to start to list this out. Okay? Let's list out A, H, K, X, Y, Z1, Z2. So on this guy here, did you work? My A, I don't know. The H, I don't know. K, I don't know. I'm not sure if I have a point yet, but I do have a 0 of 3 and 5. Okay. What the heck does which verifies f of 2 is equal to negative 6 even mean?
I think that gives the point.
Yeah. Don't overthink it. If they write it like that, do not overthink it. What I want you to do every time you see something like this, literally just beneath it, it gave you an x and a y. F of 2. So for this function, when my x is 2, my y is negative 6. So that's suggesting to me that I have a point of 2 and negative 6. 2 and negative 6. So let's start by finding the rule. Well, I'm going to use my zeros form. And I'm going to just plug everything in as I see it. Negative 6a. 2 minus 3. 2 minus 5. I'm going to double check that I plugged that in right. Yeah. And then negative 6 is equal to a. Negative 1, negative 3, negative 6 is equal to a times positive 3 divide negative 2. So now that's one aspect that I had to find. I now know that it's facing down because it says a is negative 2. So this is the one I'm going to choose, not that one. So when I get my final answer for k, I know that my range is going to look like that guy right there. Right? Because it has to, because it's facing down. Okay. Once I get that, I've got to go ahead and find out what k is. Jeez Louise, how the heck do I find out? What? What do you do?
You do Z1 plus Z2 divided by 2.
Awesome. So if you went to your formula sheet and you go up to it, and I know I have, let's just put it down here. I've got the rule, x minus 3, x minus 5. I know when I go to my formula sheet, I've got to look for k. There's a little addendum to that where it says, I can't solve k unless I get h first. So if you want to like number this off, right? Number 1, we're going to label what we have. Number 2, we solve for a. Step 3, we're going to find out what the h is. So h is equal to z1 plus z2 divided by 2. So it's going to be 3 plus 5 divided by 2. H is equal to 4. So now, step 4, I can solve for my k. Right? So whatever, I can use this formula here, a h minus z1, h minus z2. Right? So now I can go ahead and plug in everything I know. So negative 2 was my a, my h was 4, minus 3, 4, minus 5. And so 4 minus 3 is 1, 4 minus 5 is negative 1. So it'll be negative 2 times 1 times negative 1, right? So that's going to give me a positive 2. So in the end of all of this, when it was saying, what is the range of this function? Well, I'll just go back to this guy right here. Yeah. I'll zoom in a little bit too. what I'm going to do now is say that because my k is equal to 2, and because it's facing down, the function will be negative infinity to positive 2. And that would be the final answer. Okay? So just to reiterate, we're finally in the land of we find a rule so that we can use a rule, right? I found a is negative 2 so that I could go through this process here. Okay? Any questions on that guy? Because that's a jump up, right? 4-step question. An exam question like this is like a light version of an exam question. Usually they have 5 or 6 steps, so this one only has 4. Okay? But yeah, that's all I'll say. Next guy. Love the vocabulary on this one, or the nomenclature, or whatever you want to call it, that we're going to dive into. I'll leave that up there for a sec. Okay. What is the rule of the function f that has a range of negative infinity to 4 and is positive over the interval negative 1 and 3? What in the heck is happening there, Tegan?
Well, we know that our k is 4.
Mm-hmm. So my k in this case is 4. Perfect. And that's just because it says range. Okay? So that makes that guy my k. Go back to your memory aid and see if you can remember. Is positive over the interval negative 1 and 3. What is that telling me? What is
Do you
that?
know that a is negative then?
Yeah, because the range says negative infinity to 4. So I know it's facing down because it's reading from the bottom up. But what is positive over the interval? Let me just... Positive just means
It's the x.
where is it above
the x.
where is it above the x-axis? So it's, if I draw this out now, negative 1 is the first 0, 3 is the second 0. That's what this is telling me. That negative 1 is 0, 1, right? And 3 is my second 0. So positive over the interval, okay? Now this guy's just saying find the rule of it, but just using a lot of discrete vocabulary. And well, hold on for a second. What else do I need to find before I solve this guy?
H and
I gotta find h. I either need to find another point on here because I have z1, z2, and if I have a point, I'm good. But I don't have another point. All I have is k. So is there a way for me to find a point? No, not yet. It's nowhere to be found. They didn't say y-intercept. They didn't say initial value. So how do I find this axis of symmetry?
You need to find h, right?
Yeah.
Could you do z1 plus z2?
Yep.
Oh, yes.
Well done, sir. I would say so. So the h is going to be equal to positive 1. So I can now input that in my list. And again, if I have a choice now between solving in vertex form and factored form, we are going to work in vertex form. The only thing that's tough now is, well, I have hk. What's the point I'm going to use? What's the point I'm going to use? Yeah. So I'm going to just say positive 3 and 0 so I don't have to deal with negatives, right? Make my life a little bit easier in that case. Positive 3 and 0. And then now I'm going to combine that with the 1 and the 4. So vertex form a x minus h squared plus k. The y is 0. A is unknown at this point. 3 minus 1 squared plus 4.
I said that x was 0.
My y would be 0 in that case, because if I have a 0 of -1 and 3, it would be 3 and 0 as one of the points. So then I would inject that as a y value, and then the x would be 3. Sorry if I said otherwise. And then we would just solve, get that 4 out of there. -4, 2 squared, -4 is equal to 4. Divide by. A is equal to -1. The question said, what is the rule? So you are not done yet. You would literally just have to write negative x minus 1 squared plus 4. That would be you like satisfying the requirements of the question. All of those guys there. Okay. So this one didn't ask us to really use the rule, but it was just tougher for us to get started because we couldn't go anywhere until we were able to find out what the h was. Right? That was the hidden part of it. Was where do I get started when it doesn't seem like I have enough information? Okay? And I find those ones are the tricky ones because it's like if I start out a question and I write down Z1 and Z2, immediately my brain goes into factored form mode. But that's not always necessarily the case. So, questions on that guy? Okay. The last one we'll do for today, we've already kind of looked at before, but I'll go over it again now that we're at this point. This is like a question you're going to have on your test. Okay. I might not break it up like this though. Okay. I might not break it up by this or like this. So, question? Okay. So when I say that, what I mean is, let's just kind of list what we have and let's evaluate what it is that we're going to have to solve for. Okay. The first thing is I need the maximum height that it reaches. So that means I've got to find k. Okay. So that's what that guy is. The next part says determine the elapsed time from the moment the stone was at a height of 2.25 until it hit the ground. So somewhere around here, I've got to find a x when that is 2.25. So determine the elapsed time. I want to find the time between that point where it's in the air and when it hits the ground. So if I can find this x, I can go 8 minus the x that I solved, and I'll be able to get that little time period. It's a clunky question because it's like, why would you need to know that? But we're just taking baby steps now. So as always with the parabola question, AHK, XY, Z1, Z2. A stone is thrown upward from a height of 4 meters. After 3 seconds, it reaches a max height, doesn't say what it is. And after 8 seconds, it hits the ground and its trajectory is parabolic. So right now, this isn't just 4, it's 0 and 4. So I can write that down as a point. 0, 4. And I have one of my zeros. I'm going to put my second 0 is 8. Okay? The only other thing that I have is it says it reaches its max height at 3 seconds. It even draws the axis of symmetry for me here. So I know my h is 3. All right. I had you guys reason through this one the other day. I'll let you think about it for a second as well. How do I get started when all I have is h, I don't have k, I have 1 point and only 1 0? Yep. The 0?
Like y equals a.
Y equals a. X minus Z1.
Right. Well, I can put that, but the only problem with that right now is like I don't have enough information to solve for it just yet. I need to figure out maybe that 0 right there. Yeah.
You just count between the 3 and the 8, then you then you count the same number, but from 3 to backwards.
Yeah. So then it's basically a logic and reasoning kind of puzzle in this case, where it's if I have my axis of symmetry and a 0, I can always find the other 0. Because I know that if the distance between the axis of symmetry and I've kind of drawn over it, that's a 3, and this is an 8, then I know that distance is 5. Which means the distance from the axis of symmetry to the other 0 would have to be the same. So I've got a -2 as my Z1. So what does that mean? That means I'm going to have to do this in zeros form because I don't have a K. So that kind of stinks. Yeah. So on this guy here now, I know I'm going to use zeros form. Y is equal to A, X minus Z1, X minus Z2. Okay. We'll plug this guy in here and solve for it. We're going to run out of time before we finish this guy up. So what I will tell you right now is you would rearrange this, solve for the A, and get that. You would then use the zeros form to find H and then find K. Right? You have formulas for that. What's tough is you would then have to convert it to either general form or vertex form, because we have to solve for an x value when y is 2.25. So you'd have to convert it and then either use your quadratic equation, right? Minus b plus or minus, right? Or we're going to use h plus or minus square root of negative k over a. We don't have enough time to go through this guy in full, but expect that to be a type of question that you have on the test on Thursday. Okay? We'll work through this guy in full later.